All right. We'll try to do a couple of easies, a couple of mediums, and maybe one hard today. We'll start with max depth of a binary tree. Alright, given the root of a binary tree, return its maximum depth. The binary tree's maximum depth is the number of nodes along the longest path from the root of the node down to the furthest leaf of the node. Okay, so my opinion here is that we should consider doing a recursive algorithm. So we would consider doing, we could probably do it in one line. Return math.max, and we'll do if not root, return null, and we'll do max depth of root dot left, just looking at this code here, and max depth root dot right +1. Sorry, this should be 0. And yeah, we could do it one line. So if we have an element, then we will get the max of the left and the right, and then count this one and sum them all together. Otherwise, we return 0. This one's pretty straightforward, pretty easy. Hopefully we're not misunderstanding though. Max depth, just misspelled it. Submit it. We did get the 0 milliseconds, so that's great. Let's look at one of the top solutions. So they did something similar. If there's no node, they go left, they go right. They take the max of the two, add 1 to it. So just a few more lines of code than we did, but got pretty similar solution, pretty similar runtime. This is also surprisingly slower. I guess it might just be by chance. It's pretty much the same code that we have. This is very close to the code that we have as well. This one gets a little bit complicated, it seems. It doesn't use recursion. So let's see if we can understand this one. Let's look a little bit deeper here. There's the queue. Well, there's something in the queue. The size is queue.length. Ah, interesting. But then there's this. I is less than size. Node queue shift, which would pull the node at the front of the array. Node left, queue push left, right, push right. And then level plus equals 1. Wow. So basically it's like building out an array one layer at a time. And if we eventually hit the ending where there's nothing left in the queue, then we're done. And the number of times this while loop happened is determining our level. It's a lot more involved. Wow, interesting. So they avoided recursion. Excuse me. They did push and pop. Nothing here seems terribly slow to me, though. So I'm curious why this one's considered slow. Could simplify it a little bit, but I don't think that really helps. And as a matter of fact, they have the recursive solution here. So they do know that this is slower. And they know what is faster. Anyway. Okay, well, that's that solution. Alright, let's see what this is all about. Path sum. Given the root of a binary tree and an integer target sum, return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum. A leaf is a node with no children. Okay. I feel like we're going to have if not root and not target sum. Return true. And my idea here is basically as we go deeper and deeper into the tree, we're going to subtract from target sum. Are all the values positive? Okay, the node values can be negative, and so can the target sum. So we don't have to think about that. So basically, if we hit a root, if we hit a leaf, and we are at 0, then we return true. We can actually do return not target sum. So that we can reuse this branch. But otherwise we need to do return has path sum root dot left target sum minus root dot val, referring to the documentation up here, or has path sum root dot right target sum. We could just say next here. Just cache the value. So we can attempt to run it, see if we understand the problem. So it's empty, target sum, the output is true, but expected false. Does it say that exactly? Since the tree is empty, there is no root to leaf paths. Okay. So in that case, I Or we consider laying out the function a little bit differently. Do that. If there's no root, then we'll return false. If then we need to see if we're at a leaf. We'll say if not root dot left and not root dot right and not target sum, return true. So if we're basically at a leaf, excuse me, is leaf, otherwise we need to go down the left and the right path. Okay. Got false, but we expected true. So not left and not right. And it's a leaf. It's a leaf and target sum is 0 essentially. Then we'll return true. Otherwise we need to take target sum minus the current value and go down a level. Oh, but this should happen sooner, I think. Yeah, this needs to happen first because we need to apply the value before we consider whether it's a leaf or not. We don't have to do, the order doesn't matter, but in terms of leaf or next, but we do have to do the subtraction first to consider the value as part of the sum. So we can submit it. And we're on the slower side. I say slower, but it's only 1 millisecond. So what I'll do is just trying to think of ways that we can potentially improve the performance here. I don't think that will do it. This will probably be 2 milliseconds now if we're unlucky. Okay, in that case, let's just see what the best solution was. So they have a similar solution, if not root false, if not left, if not right. Oh, okay, so they kind of like opted out early. Rather than checking if it's 0, they said if it's the same value. And then they minus later. Surprising that that's better performance. Maybe subtraction is more expensive than equals, but they do the subtraction twice. I only did the subtraction once. And then this one's very complicated, it seems. This one is like calculating the sum of each path, and I suppose detecting if it's at the end of the path or not. And if it is, then it sees if the sum is correct. If it found a path would be true. So just a little bit overhead with using a global variable, probably using two global variables, and having to do adding the sum, subtracting the sum. It's really curious. Hey Suha, how's it going? Move on to another problem. Let's do linked list cycles. So given a head, the head of a linked list determines if a linked list has a cycle in it. There's a cycle of the linked list is some node in the list that can be reached again continuously following the same pointer internally. Position is used to denote the index of the node that the tails point is connected to. Note that the position is not passed the parameter. Return true if the cycle in a linked list, otherwise false. So I vaguely remember solving a problem like this before. And I had this idea of you have two pointers and one of them goes one at a time, the other goes two at a time, and if there's a cycle, they eventually meet up. And if there's not a cycle, question mark. But the idea is that you can do it in very small amount of memory. Whereas you might think that you have to like use a map to solve it. But I'm trying to think if for this example, if we had one that goes one that goes two, it goes one, and then it goes two. So I'll do let one equal head, let two equal head dot next, and I guess while two, we'll keep going. And if we reach the end and there's no loops or there's no cycles, I'll say if one equals two, we'll return true, there is a cycle. And then we'll say one equals one dot head, two equals two dot, why am I saying head? Next. Dot next dot next. Yeah, so that is the follow-up. Can you solve it in constant memory? Because otherwise you might think to attempt it in linear memory. But let's see if it's even right. It might have been too long since I've solved this problem. And we do solve it, but it's not super fast. I wonder how you make it faster. Let's look at the better solutions. Interesting that they somehow have... Shouldn't they both start at the head? Apparently, that seems to be the case. But then... wouldn't this have to come first? Fortunately, it doesn't make it faster though. Basically the same code. I'm curious about this. So I would have thought something like this would throw an exception. Next. Oh, because I do this. Just curious. Maybe this lets them opt out earlier. And do one less loop. Maybe. So when they did it by using up memory, they were able to do it faster, which makes sense. In order to do the cycle, you have to go through at least once in some cases. This one, you go through once. Check out Playscape later. What's Playscape? Did I misread it? Wait, did I misread it? Am I... It makes games using AI. Playscape, game, AI. Oh, I see it now. Playscape.gg. Nightmare on Play Street. Cook me up a fun game, surprise me. Alright. Well, I think this is the best solution that we end up with, so... Excuse me. We'll try... let's think of a game done. What? Right when I start typing? That's wild. Let me sign up. Okay. I want to play a side-scrolling Metroidvania with aggressive power-ups, leveling system, powerful gear, quests. How crazy can we go? They have a CLI version. leveling system, powerful gear, quests, and a rich story dialogue. All right, getting ready. Will this be enough? Oh, it takes a while. I hope that is to say, okay, there's no, is it saying that I gave it 165 characters or that it's generating 165 characters? I don't think 165 characters is quite going to do what I want. But we can view the technical details. So it's generating one HTML file, I guess. Okay, well, while we're waiting, we'll do another easy problem. Let's do single number. Given a non-empty array of integers nums, every element appears twice except for one. Find that single one. You must implement a solution with linear runtime complexity and use only constant extra space. Okay. Linear and constant space. Use XOR. Alright, I'm thinking about some creations. How do you use XOR to solve this? I mean, it's saying to do it in linear. How do you use XOR to... I know that like XOR would make it so that one number, you flip the bits-ish, exclusive OR on the bits of the two numbers. But can you... Oh, I think I see what you're saying. So like return result, const result equals num sub I sub 0. I is 1, result exclusive OR equals num sub I. Okay, so it's like using this property that like a 2 and a 2 will negate each other and make it 0, but then once you combine it with 1, you'll be left with 1. The 4, forget the 4 for now, but the 1 and the 1 would negate each other, 2 and the 2 would negate each other, you'd just be left with 4. Good call. Except... Oops. Let's run it. Submit it. I am curious what the hint would have been. It does say bit manipulation as one of the topics. Yeah, think about the XOR property. Good call. See how our game is coming along. How do can I refresh? Seems to not have worked. I have no messages left, so I can't do anything, it seems. If you have a game that you've generated, Zuha, that you want to share, I'd be interested in seeing the result. Next question. All right, let's do it. Let's do this one. Given the heads of two singly linked lists, A, B, return a node at which the two lists intersect. If the two linked lists have no intersection at all, return null. For example, the following two linked lists begin to intersect at node C1. The test cases are generated. No cycles anywhere in the entire linked list. The linked list must retain the original structure. The inputs to the judge are given intersect value, list A, list B, skip A, skip B. Okay. Can you write a solution that runs in OM plus N and uses one memory? Constant memory. M plus N is the size of both lists. I haven't learned linked lists yet. A linked list, you could kind of see the definition here. I'm not sure the screen is big enough to really see. But the idea is a traditional array, you have elements stored back to back in continuous memory, but a linked list is more of an object, like a data structure, where you have a node that points to the next node, and that node points to its next node until eventually you hit null, which indicates the end of the list. A flexible data structure allows you to easily add and remove elements without having to shift them over. So, trying to solve it in big O M plus N. That's challenging, and also big O constant memory. Going through each one only once without using extra memory. So if we go one, go one, go one. We have to return the node. Intersect the node's value. Is there a hint? Topics. Okay, hash table and 2 pointers. But it's saying how to do it in memory 01. I could do it with a hash table, but like, how do you do it without a hash table? That's what I want to know. And M is in the M. Number of nodes in list B is in the N. What are you talking about, M and N? Inputs to the judge are given as follows. Your program is not given these inputs. Intersect value. Value of the node where the intersection occurs. This is 0, there's no intersection node. Is that what you want me to return, the value or the node? The value. Okay. List A, starting from the head, get to the intersected node. Skip B, number of nodes to skip ahead in. List B to get to the intersected node. Oh, okay, I'm misreading this. Skip A is the number of nodes to skip ahead in list A. Get to the intersected node. M plus N. Can't use extra memory. So like, to some extent, wonder, can we mess with the original data structure? They have to retain the original structure. So I can't even like try to reuse the memory. So I wonder if there's, but we can't go through the list more than once. Log of m plus n. Like literally we can only go through, not even the whole list, we can only go to the common item. If there is one. Once, because m is the amount of elements here and n is the number of elements here. Are there any properties of this? Turn it off, for example. There's no cycles. Just trying to figure out how can you know which of these lists is longer. I would like to see the solution, so I'll just do const map turn 0. While head A equals head A dot next. If head A dot val map sub head A val return true. And then this would be true. Now we have to do the same thing for B. Just to see if I'm understanding the problem. Okay, maybe I'm not understanding the problem. Wait, I supposed to return? Intersected at 8, intersected at undefined. We'll do that. Oh, why am I doing intersect? Why am I doing true? Am I supposed to return this? This? Okay, it's returning 4. Does this work? Intersected at 1. Skip A2. Skip B3, 0, 1, 2, 3. So it's supposed to intersect at 8, but it thinks that it's intersecting at 1. They both have 1 in common. Is it just by chance? 0, 1, 2, 0, 1, 1, 2, 3, 0, 1, 2. Do they, is there somehow that they have their own hashing? We are going down one of these routes. Technically speaking, you should never do that. Now it thinks we're intersecting at 5. Let's do... Let's try that. I guess we gotta do like that. Wait, what are we supposed to return? There's no intersection. So what do I return? Do I not return? Okay, you say so. Now this would be log m plus n. No, it would be more. It'd be more than m plus n. I am very curious. Is there a hint? Two pointers. I'm very curious. I would like to see the solution. While they're not equal to each other, return P1. P1 is P1. P1 is head A, P2 is head B. If P1 doesn't have a value, then it becomes head B. Otherwise it becomes P1's next. P2, then it becomes head A. Very curious about this. Basically trying to go one more every time. But I feel like there's no... What's the point of this? Why would you go head B? You'll never catch up. Why not just opt out early? Like if either of them end up being null, oh, is it just because they also, oh, as they get to the end of the array, do they eventually both end up being null? How is this the most efficient? Okay, they used our solution. Yeah, what is this solution? If we were to look at the description, we would start here and here. This would move over, this would move over, this would move over, this would move over. I don't know what I need to do. Take a screenshot. circle it in red. Rotate it. Okay, so I'm gonna rotate this one too. So the algorithm is they're both pointing here, then they both move over, then they both move over, then they both move over, and they both move over. But this one goes over here, and this one goes over here. How is this fast? I'm so confused. Okay, so one iteration, another iteration, another iteration, another iteration. And then this one points to null for a little bit. This one points here. Yeah. And then after that, this goes down. This points to null. This moves, and this moves. Now they're kind of aligned. And they'll meet up here. But there's no way that's faster. Is it? Because you've gone through it twice. It's not, I mean, it's faster, but I don't understand how it's faster. I guess average case, it's faster, but. And they do it in memory. They go one. Wow. It's a different solution. But there is a solution. This is fast. They use a set. Okay. Let's do a medium problem. It's not the one I wanted to pick. Maybe we could do rotate image. You're given an n times n 2D matrix representing an image. Rotate the image by 90 degrees clockwise. You have to rotate the image in place, which means you have to modify the input 2D matrix directly. Do not allocate another 2D matrix to the rotation. Okay. Wait, rotates it how? Because these seem to be rotating two different ways. Okay, rotates it that way. I'm so confused. 15 is here. 50. Oh, okay, I'm not confused. Alright, Alright, so what's the algorithm to do this in place? This goes to this corner, this goes to this corner, this goes to this corner. This seems like a horrible algorithm. Seems terribly difficult to write. Just this idea of like playing this kind of snaky game and rotating things one by one. So but that I was gonna say I can kind of imagine, but we can't allocate more memory. So I know that there is some kind of matrix rotation matrix that we could potentially use, but not really a matrix. Like there's, for example, what I'm trying to say is there's a matrix we can multiply this by that would result in this matrix. If we could figure out what that looks like and figure out a way that it doesn't take up more memory, then we could do the rotation potentially in place. But then the concern would be, once we store it back in place, how would we make it so that the multiplication doesn't get affected by future multiplications? Interesting. Let's look at the topics. Math. Yeah, something tells me that you don't actually just move stuff, you do a multiplication. Needs some kind of a guide. How can I move this here while also moving this here, while also moving this here, while also moving this here? How can I move 4 things at once? And in this case, how do I move? Or maybe I'm always just moving 4 things at once. Maybe I am just moving 4 things at once and I'm just starting on the outer layer and working my way in. Maybe it's just that straightforward. So I'm thinking did this work yet? Let's see what other games people have built. And then I'll get back to this. Does anything work? Oh, that's sad. Okay, well, back to it. I think we gotta do like for const layer equals 0. Layer is less than n divided by 2. I plus plus or layer plus plus. And this is going to represent how we're working our way inwards. Starting at layer 0, the outer layer, and layer 1, the inner layer, and so on. So 0, 1, n is 4. When we hit 2, this will be 2. 2.5, 5 will be 2.5. So hit 3. Okay, this should be fine. And then we have to do for let x equals layer. X is less than matrix dot length. Is it always a square? It has to be a square, right? Yeah, it has to be a square. X plus plus, but we need to subtract layer. And then we'll return matrix here. And we'll do A is basically just grabbing the 4 elements that we need. Matrix sub x sub layer. Yeah. B is matrix sub matrix dot length minus x minus 1 sub layer. See. Ooh. Similar. This would be matrix dot length minus layer -1. And then D is this, except the X. The thing that X affects changes. So this one I'm imagining going left to right, but this B is going top to bottom. So X is actually affecting this. We're doing plus X here as well. And D, the X is going to be here. And it is going to be minus. Oh, I'm confusing things. So this is left to right. This should be top to bottom. So in that case, we should be adding X here. This should be right to left. And this should be bottom to top. Minus X, 1, something like that. And then now that we have all those cached, we can rotate them. So this is A. So this is A. A becomes D. This is B. B becomes A. So B becomes A. C becomes D, B, and then D becomes C. Something like that. I mean, we'll find out when we run it. Let's do this. Let's do const n equals matrix dot length. Then we could just use n everywhere that we used matrix length. Aye. We'll run it. Assignment to constant. Layer is const. Okay. We don't return anything. Okay, let's go through these one by one and really think through them. My hope is, so I'm hoping that it doesn't really matter what I call X or Y here really. If the left or the right is X, rotating should be the same. Ideally, I would have just been rotating incorrectly, but it seems like 9, 9, 1, 1. Seems like we're not preserving things in an expected way. So let's figure that out. So I still like the idea of layers. And I like the idea of X working within those layers. X is less than n minus layer. Actually, 2 times X. Let's try that, just in case it was that simple. Okay, so we still have duplicates though. So I want to do console.log layer and console log X. Let's just do layer X. Like that. We'll run it. Just a sanity check. So yeah, I don't expect to have more layers, and I do expect this to run 3 times. So all of that looks good. 0, 1, 2, that looks good. So we'll do that just to see that we're getting the 4 corners that we expect. So we should be getting 1, 3, 7, 9, which is not correct. So it looks like our B let's have a 9, 9. So C and D are certainly wrong. B is questionable. So this is right to left at the bottom. If that's the case, then minus X should be here. And we should start at the end. Start at the end. Minus X each time. Minus 1. And then the Y would be start at the end. Minus layer minus 1. Or D, which is bottom to top. This should be X. N is minus layer minus X. Right. So I want this to be 1, but I want B to be 3, but D is 3. right? So 1397, then okay, well, the second one's not going to matter much if all of these are incorrect. So that's correct. There's that. Okay. So 1397, 13 should be 1397. Yeah, that's how I want it. Because it'd be left to right, which is left to right, top to bottom, then right to left, and then bottom to top. So the first four look fine. Then the next four should be 2684. And that's just not correct. It should be 2684, and we have everything. It seems to be wrong. We have 468, but we don't have 2. So makes me wonder if the order is not ideal. I guess the order is not ideal. Potentially. Just so that we're getting the values we expect, although it should work either way. I'd rather see the correct values. Okay, and I said 2684. So we have 2. So it seems like this one's right. But this one is not. This one's actually getting the center. Top to bottom. It's going top to bottom, then this needs to be n minus 1 minus layer. Two, 6, 8, 4. So D is incorrect. Bottom to top. So this should be, the X should be layer, and the Y should be layer and minus layer minus X minus 1. No. Oh, and then there's the fact that these need to change too. I cannot read property undefined. Alright, so this is bottom to top. The first one is the Y, which should be N. Oh, we got a minus X here. And then layer. And we have to go through this all again. Just make sure everything matches up as expected. I don't think I copied it. I'll run it. Okay, so we did 1997. So we're back to being wrong again. Yeah, the Y would be what layer we're on, the X would be the X. 1 is correct anyway, B is wrong. B would be n minus 1 minus X minus layer. I don't think we minus layer, we just minus X. Run it again. 1997. 1. So B is still wrong. It's top to bottom. The X is determined by the layer. Should be 3. 397. So the X is 0, so it'd be 0, it'd be 3 minus 0 minus 1 is 2. So it'd be Y is 2. So actually, this is layer. No, it's X. It's top to bottom. But why is it N? It's not N. This is the Y. This is X. It's just X. One, 3, 9, 7. Okay. I don't think this changed. I don't think I copied it. That's that. Run it. One, 3, 9, 7. That is expected. 1, 3, 9, 7. Perfect. And then it's 2, 6, 8, 4, 2, 6, 8, 4. That is expected. Perfect. And then it'd be 1, 3, 9, 7. Okay, so we actually need this. So n is 3 minus 2 times 0. So layer is 0 initially. Maybe we just do minus 1 more. Okay. So we have the second example, which should be 5, 11, 16, 15, 5, 11, 16, 15. Nice. Then it should be 1, 10, 7, 14, 1, 10, 12, 13. It should be 1, 10, 4, 1, 10, 12, 13. 1, 10, 12, 13. Okay, that is correct. My mistake. And then it should be 9, 7, 14, 2. That's correct. Okay, so the problem is we're not going through multiple layers. We're rotating the outer layer, but not the inner layer. So we can figure that out by looking at this. Oh, we don't need to multiply by 2. Okay, so now we're doing multiple layers. 5, 11, 16, 15. That's nice. 1, 10, 12, 13. 1, 10, 12, 13. Nice. 9. 9, 7, 14, 2. Nice. And then we go to the inner layer. And the inner layer would be 4, 8, 6, 3. 4, 8, 6, 4. So our selection for D is incorrect. So I guess the question is, does layer not matter for one of these? Probably the one with X in it doesn't matter. Which means this one also doesn't matter. Should get rid of this console log. Get rid of this console log. Could run it. Nice. So I say we submit it. I'm curious about performance. Performance is terrible, apparently. I would be curious to know if it's mainly because of extra variables, or if there's like just a simple solution and I just don't know the fast maths for it. So let's do this. Actually, let's just submit it again. Let's just look at the best solution. Or I just have to remove comments. It's fine. Look at the best solution. Oh, wow. So they go through each element and then they swap the places of some elements. I feel like this one has the potential to, and then this seems fairly expensive. No, reverse? Okay, it's not reversing the matrix, which I guess it's not really that expensive. It's just reversing the array. Reversing each array. Okay, somehow this is the best solution. Basically just a really complicated switch. I mean, you don't really need this, I feel like. It's kind of pointless to do this if they're the same. They did it in 2 loops. They swap everything where j is less than I. It's so interesting, the solutions people come up with. Where mine is just like, just swap the 4 things. Oh, stringify. What is that? Turn it to JSON? Matrix multiply or something? What is MP? Just map. Oh, well, okay, so they didn't follow the prompt. They created new memory, which we weren't allowed to do. They didn't do it in line, so they actually made the problem easier for themselves. Oh wow, they did a similar solution with the reverse and all. Okay, I mean, looking at other people's solutions, I am happy with my solution. I did think it was challenging though, for sure. Alright, how about power xn? Limit power xn, which calculates x raised to the power n. And I imagine that we're meant to do this without using the math.pow function. So the question would be, what are we not allowed to use? Nothing really tells us. So I guess what I would try first is if we gotta handle negative numbers too. That's not fun. So do let power equal n, and we'll do while power, and we'll also do result equals 1. Yeah, we'll always be at least 1. We'll return result, and if power is 0, then yeah, we'll end up being result of 1. If n is greater than 0, else negative. And we can say power divide equals 2, and we can say result equals do we handle decimal? Just negative? Do math.abs while power is greater than 1. So x? No. Result. So thinking about this, if it was 2, it should be squaring it. Negative exponent returns 1 divided by result. greater than or equal to 0 will return result, otherwise return 1 divided by result. We don't want to accidentally divide by 0. I think. See how this does. So we output 1, x is 2. So let's think about this. X is 2, n is 10. I guess we gotta do done, what we've done so far. Done 0. While done is equal to power. Less than power. Oh, but then what if we get super close? Why is the output only 1? Okay, let me go back to this solution. Let's put these on multiple lines. So this should be 10. This should be 1. Power is 10. So result times equals. I'll just say this is x. And we'll do a escape hatch if n equals 0. Return 1. Is it only whole numbers by chance? I think n has the potential. N is an integer, which is helpful. Result equals x. We can move this later. Power is 10. Result is result times result, which is 2. So if we store 4, and power divided by 2 is 5. And then is power greater than 1? Yes, it is. So result becomes 4 times 4, which is 16. And then power becomes 2.5. Still greater than. So this becomes 16 times 16, which is 256. And then this is 1.25. We do it one more time. We shouldn't do it one more time. We're kind of overkilling it at the moment. So one thing we could do is just do it with recursion. We could do if n equals 0, return 1. And if n equals 1, return x. Otherwise, we'll return my pal x n times my pal x n, and we'll divide by 2. Except we don't handle negative. Actually, I don't even think we ever properly cancel out because we have to floor this. N divided by 2. F. Semi. The only question is, how do we handle negative? I think we did, at the very least, we did a tilde here. We'd at least break out, but we wouldn't have the right values. Okay, interesting. We got 256, but we expected 1024. So we need to multiply 2 one more time. So, thinking about how this breaks out, it'd be 2 to the 5th times 2 to the 5th, which would break out to 2 to the 2. We do end up with an odd man out. Maybe we just do if n -1 less than equal to n and n less than equal to 1, we return x. So we can can't do that. We'll do this instead. Try running this. Still not handling decimals or negatives. Are we multiplying out? Yeah, 256 by 256. Wonder if that's the case. Try that. But we'll never get 1 or -1. When do we floor it? Turn 1. Turn X. And then we have to use power instead of N. Try that. We never end. X equals 2, N equals -2. So this should become 1. That's still not enough. I guess what we could do, we could do left math.floor and then right equals n minus left. And then we could do left, right, and then that. We don't even need that. We just do n. Great. That's awesome progress. I just say const power equals math.abs of n, and then use power if we're doing absolute value, it's always going to be positive, and then power, and then we say const result equal, I will return x greater than 0 result, otherwise result divided by result. Okay, you'll do a console log of x n left, right, result. Check that out. And that's because we're going down this route, because they both end up being 1. And then it should be n. My mistake. Excellent. We'll run it. Oh, we'll submit it, fine. I would imagine that if there's an issue, it's performance. Input, output expected. I have a solution in mind, but I'm trying to figure out the least amount of changes that we could potentially do this in. Essentially, we should be getting 1 times the original value, and then we should be logging a result. We should be getting a result where the right side would be 1 times 1x. That would give us that. X over there, and the left would be 1. Because it would be power, which is -1 divided by 2, which would be -0.5. -0.5 floor would be 0. Power is 1. 1 minus 0 is 1. So it's 0 and 1, 0 and 1, 0. This left side would be 1. This right side would be 8.9. The n should still be -1. So ultimately, we should be going down this route. So the question is, why are we not? Submit it. Right, we've exceeded the output limit. It's a shame. Okay, let's code it. So 8.9, -1. So pow is 1. Oh. We hit this case immediately. Okay, fine. N equals +1. N equals -1. We'll do that. I guess we could do N here as well, which means we could do power later. Yeah, that's fine. We've exceeded the time limit. Okay, it seems that splitting the problem in half is not good enough. which makes me think we probably had to use like binary. Or not, I don't know. Okay. Let's look at a solution. Oh, that's funny. So this is a floored division. That's an interesting idea, okay. So their idea is basically there's no reason to do this work twice. So just call it once. We'll say const result equals once times once. And rather than that, left do left left. We can steal that syntax, I suppose. Double division. Oh, that's not real thing. Oh, that's Python. Oh, that's a shame. Must have been looking at Python code. And we need to add another thing, another check to where is power is n and 1. Basically, is n odd? If n is odd, then we need to add one more x, otherwise we don't add anything. Try running that. We need to multiply, I suppose. Output is 0. Oh, by 1. Okay. One less const. Just reducing the number of variables. What are the parts of a... I don't know what they're called. There's product. I don't remember. Okay, let's submit it. See if we did any better. Okay, cool. And then we can look at the top solution. They cared about 1. They cared about less than 1. Calculate half. Yep. They floored half. X saw if it was even or not. Yep. And then did the division in a different function. Yep. Nice. What difficulty was this? Medium. All right, just a moment. All right, I think I should stop right now. I think we did like 3 or 4 easies and 2 mediums. But yeah, it was good. It's fun. Thanks for joining in and for chatting. I think it's unlikely I'll be on tomorrow. I'll probably be working on another video. So yeah, thanks again. Bye for now.